In this example problem, what it states is a ray of light enters water at an angle of 23 degrees from the normal. So the angle here is going to be 23 degrees. Here's our normal. What is the angle of refraction in the water? So what we have is we have a light source in this corner, and it's shining light. The angle between the light and the normal is going to be 23 degrees. The light does one of two things. It's either going to reflect off at 23 degrees because the angle of incident is going to be equal to the angle of reflection, or it can be refracted. So this light here is going to be reflected off the surface as such, or it can be refracted. Now the question is, what is theta 2? And what we have here is we have n1 sine of theta 1 is equal to n2 sine of theta 2. Now n1 is going to be air, and it's going to have an index of refraction of 1. This is going to be water, and it's going to have an index of refraction of 1.33. So we can substitute now in 1, which is going to be our index of refraction for air, sine of, now the angle relative to the normal is 23 degrees, is equal to n2, which is 1.33 sine of now the angle for the refracted light, and that's going to be theta 2. Okay? Now if you solve this, so you can solve sine of theta 2 is equal to the sine of 23 divided by 1.33. We'll just leave this one out. We come up with the sine of theta 2 is equal to 0.293. That's what this term is going to be equal to. We then take theta 2 is equal to the inverse of the sine of 0.293, and this will be equal to 17 degrees. So the angle theta 2 is going to be 17 degrees. Now that makes sense because the index of refraction is greater than the index of refraction for air. So the index of refraction for water is greater than the index of refraction for air, which means that theta 2, the refracted light, is going to bend more towards the normal. Thus, theta 2 is going to be smaller than theta 1 because the refracted light is traveling through a greater density or a more dense substance than in the air. If you have any questions on this, please let me know.